Now remember that the histograms, the rectangles, the bars, they're similar. They look more or less the same and they have a relationship with each other. So thinking about the class width in centimeter and the class width in unit are equal to any other class width in centimeter in the graph paper with respect to the unit. The unit class width is calculated using the upper boundary minus lower boundary. So when you talk about the unit, it is the upper boundary minus the lower boundary. For this particular sum, there is a gap in the data, so that means we have to do a continuity correction. So the upper boundary for this class is 19.5 and the lower boundary is 9.5. So if you subtract it, it's like 19 minus 10 plus 1 is 10. So that's the class width in unit. So whenever we are talking about the class width in unit, we can find it by the upper boundary subtract the lower boundary. Now the class width in centimeter is what we have to find, and that is the dimension. That's the dimension. So if you have this as the histogram, so this is like length and this is the height of the rectangle. So this is the class width and this is the frequency density or the height of this rectangle. Whenever they are talking about the dimensions, they are talking about this one in centimeter and this one in centimeter. The centimeter is referred to the graph paper. The graph paper is marked out in small boxes and they are all centimeter. So let's begin. So in number 1, the information that is given here is the bar representing the 20 to 29, this one here, 20 to 29. So it has a frequency of 18, so it is 2 centimeter wide. So they are talking about the class width. So using the class width, we can write class width for the given information. So this one is wide 2 centimeters. This is 2 centimeter wide. Now the unit of the class width is upper boundary minus lower boundary. Remember there is a gap here, 29 to 30 there is a gap, so it is going to be 29.5 minus 19.5. that would be, in a shortcut we can do 29 minus 20, which is 9 plus 1 10. So the class width is 10 unit, equals to, now we want to find this one out, this one. So this was given equal to what we want to find. So this one, it has a class width of, again, so this one, it is a class width of, since there is a gap here, so 34.5 minus 29.5, that would be 34 minus 30 is 4 plus 1 5, so this would be 5 unit. So we need to find the unknown centimeter, so let me call this x. Therefore what we can do, if we cross multiply, this would be 5 into 2 divided by 10 centimeter. This is the dimension. Therefore x equals to, this is 1 centimeter, so it is 1 centimeter wide. We now need to find the frequency density. The dimension refers to the class width and the frequency density. So similarly, for frequency density, it would be the centimeter that is given and the unit of the frequency density, which we can calculate from here, and again equal to another 1 centimeter divided by unit of the frequency density that would be given. For finding the frequency density, the formula is frequency density equals to frequency divided by class width. So that's it. So let me do it here. In the exam, it's always recommended you do one sum after the other vertically below. So frequency density, so the frequency density for this group again, 20 to 29, is 7.2 centimeter. High means frequency density, 7.2 centimeter. So the unit is going to be frequency divided by class width. Now this one has a class width of 10 and this is the frequency, so frequency divided by class width is going to be 10 divided by 80 divided by 10 is 1.8 units, equals to, now we need to find the height of this one. Remember we're still in number 1, so the height of this one, so we need to know the frequency density unit. So 24 divided by 34, this is going to be 5. So 24 divided by 5 is going to be 24 divided by 5 is going to be 4.8. So this would be 4.8 unit. So the unknown now, the height, let me call this y. So therefore 7.2 into 4.8 divided by 1.8 centimeter is the height. Therefore y equals to 4.8 into 7.2 divided by 1.8 is 19.2 centimeter. That's the dimension. The next one is class width. Let me put down the given information again. So here the class width in centimeter is 2 centimeter and the unit is 10 equals to, so we are interested in this one now. So this is 50 to 69, this one. So here we need the class width because of this formula, the unit. It is 69 minus 50 is 19 plus 120. So let me put here 20. And this is something that we have to find. Let me call this x again. So it would be 2 into 20 divided by 10 centimeter equals to x. Therefore the class width of the new one is going to be 2 5s are 5 4s are 4 centimeter. Now the frequency density of this one, again the given information is exactly the same, so let me copy this here. The given information is 7.2 centimeter and the frequency density is 1.8 unit. So for this one, so the frequency density is going to be frequency divided by class width. So frequency is 5, class width is 20. So 5 divided by 20, it would be 0.25. So 0.25 is the unit of the frequency and we need to find the centimeter, the height, the dimension. So 7.2 into 0.25 divided by 1.8 centimeter, that is y. So therefore y equals to 7.2 into 0.25 divided by 1.8. It is 1 centimeter.